Hopefully today I won't have a network problem. Just crossing my fingers.
Mr. Nkomo?
Yes, hi.
I'm so sorry. I logged in late because of network issues. I have a question. I got it with one of our quizzes that you gave us. With differentiation. Could you please assist?
Is it the quiz or the assignment?
The quiz. There was a question there that really gave me issues.
Okay, please give me that question.
Okay, it was fx equals ln.
Fx equals ln.
And within ln it was 4x minus 3 over 6x.
4x minus 3 over
over
everything.
everything over 6x cube 6x cube minus 2.
6x cubed or squared.
Cube, ma'am.
Cubed minus 2.
Yes, and
like
we
this.
were meant, sorry?
Like this.
Yes,
Must I close the brackets?
Close the brackets, yes.
Okay.
And then
All right.
we were meant to figure out the differentiation. We were meant to differentiate this, and I struggled a lot.
Or we also find f prime at x.
F prime, yes, ma'am, yes, ma'am.
Right. Okay. First we have linear function, right?
Yes, ma'am.
Meaning we have the outer function and the inner function, right? Okay, I'll let our inner function to be u. So, okay, we have u equals 4x minus 3 over 6x cubed minus 2, right? Meaning, okay, then I'll let the outer function to be v.
Ma'am.
Yes.
Which section are we doing today?
Optimization of functions.
Which one is that on the study guide?
Please open your study guide. I'm not going to teach you how to like.
Is it chapter 6?
I don't even know which chapter is that. But optimization, it's under differentiation. What chapter is that one?
Is chapter 5.
Chapter 5. It's 5.4.
Okay. Today we're doing optimization, but this is the question from the quiz. They asked me to do this one from the quiz, right? Then after this question, if you guys don't have any questions anymore, then we'll start with today's session. But today we're doing optimization. It's under differentiation.
Okay.
It's before.
I see it, ma'am. I see it. It's fine.
All right, thank you. So we have v equals ln u, right? We have the inner function and the outer function, right? Okay. Using chain rule, which is the derivative of the inner function times the derivative of the outer function, we'll have, okay, it says f prime at x equals the derivative of the outer function. Okay, we have v prime times the derivative of the inner function, which is u prime, right? For us to use chain rule here, we need the derivative of u and the derivative of v, right? Okay, and we can find that from our u and v, right? Okay, we have v simple because it's ln u. We can just use the laws of exponent and logarithm or derivative. So if v is equal to ln u, v prime will be 1 over u, right? Okay, then we have u. Our u is equal to 4x minus 3 over 6x squared, x cubed minus 2, right? Okay, you say for u, we have the numerator and the denominator, right? Meaning we have to use a quotient rule to differentiate this function. Okay, I'll let the upper function to be maybe w, then I'll let the lower function to be z, right? Meaning we have w equals 4x minus 3, and then we have z equals 6x cubed minus 2, right? Okay, if we have u equals w over z, and w is a function and z is a function, we need to use a quotient rule, right? And the quotient rule is saying v prime would be w prime times z minus, then we keep w, we differentiate z over z squared, right? Okay. To use the quotient rule, we need z and w and also their derivative, right? Okay, for now we only have w and z, so we need their derivative too. Okay, if w is equal to 4x minus 3, w prime, to get w prime, we need to use a power rule, right? And if we use a power rule here to differentiate 4x minus 3, we'll get 4. Okay, if z is equal to 6x cubed minus 2, again here to get z prime, we need to use the power rule, right? If we use a power rule here, we'll have 18x squared, right? So now we have w prime, z prime. We can just substitute them back here. Okay, we said u prime is equal to w prime times z minus w z prime over z squared, right? Okay, we have w prime equals 4, and we have z equals 6x cubed minus 2 minus w. Our w is 4x minus 3, right? And then we have z prime. Our z prime is 18x squared. This everything all over z squared. So all over 18x squared. Okay, this is your u prime. Okay, and we need our u prime here, right? Remember, we said the derivative of the given function would be v prime u prime. So this means we have f prime at x equals, we said it's v prime times u prime, right? Okay. We said the derivative of v is 1 over u times the derivative of u is 4 times 6x cubed minus 2 minus 4x minus 3 times 18x squared, right? Over, okay, there's squared here, over 18x squared, everything squared, right? Okay, we have 1 over u in this function, and our our given function wasn't in terms of u, so we need to substitute our u back. But we know that u is equal to, okay, which one is u? 4x minus 3. Okay. Okay, so we have 1 over 4x minus 3 over 6x cubed minus 2 over 6x cubed minus 2, right, times 4 into 6x cubed minus 2 minus 4x minus 3 times 18x squared over 18x squared, everything squared, right? Okay, we have 1 over this and this. We can write this. Okay, if
Sorry, Ms. Nkomo,
yes,
you keep saying x squared to the raised to the power of 2. Aren't we supposed to say it's v to the power of 2 instead of v prime to the power of 2?
did I say v prime?
18
It's supposed to be v. Oh, yeah, it's supposed to be.
Okay.
Wait. It's supposed to be z squared, and we said z is equal to 6x cubed minus 2. Okay, I'm sorry about that. Here we have 6x cubed minus 2. Thank you. Over, okay, here is the 6x cubed minus 2, everything squared. Again, 6x cubed minus 2 all squared. Okay, this you can write it as in 6x cubed minus 2 over 4x minus 3, right? Times 4 times 6x cubed minus 2 minus 4x minus 2 into 18x squared, right? Over 6x cubed minus 2 all squared. Okay, 6x cubed from here can cancel out with this one. And if you cancel 6x squared with just 6x squared here, you will have 1 over 4x minus 3 into 4 times 6x cubed minus 2 minus 4x minus 2 into 14x out. This is 18x squared over 6x cubed minus 2. Okay, maybe okay, minus 2. Maybe you can just simplify out. Let me see. Okay, you can write this as have 6x minus 2, and you have, okay, you can just multiply out here. Let me try that. We have 1 over 4x minus 3 into, okay, 4 times this. Oh no, let me leave that like that. 6, 8 cubed minus 2. Then I multiply everything here. What did you get as 18 times 4? Like 38 plus 30. Oh, it's 36 plus 36. That's 2. So you have 36. It's what? That's 36.
72.
That's 72. 72 plus 72. 144. Okay. Thank you. Minus 144 x cubed minus, that's 36 x squared over 6 x cubed minus 2.
144, where do we get 144 from? Isn't it 4x times 18x squared, which is 72x cubed?
It's 4 times 18. 18 times 18 is 36. Oh, plus another 36 is 72. So we have 72 here.
Yeah.
I just said times 8. 72. Okay, so we have minus 72x cubed minus 36x squared. Okay, what if we take out, we have a common factor between the two? Yes. What if we take out 6x cubed? Yeah. No, 6x squared.
Yeah, squared, yeah.
We won't have, I guess we won't have a common factor. Then the best way is to multiply again here. So we have 4 times 6, that's 24. 24x cubed minus 8 minus 72x cubed minus 36x squared over 6x cubed minus 2. Okay, we have 24 and 72. Okay, this is, so we have 24 and 72. Is it of minus 48? Minus 2. It's minus 48 x cubed. Then we have minus 36 x squared minus 8. Everything over 4x minus 3 times 6x cubed minus 2. Okay, will this get us up anywhere? Okay, let me write as it is. 48 x cubed minus 36 x squared minus 8 over, we have 4 times 6, it's 24. So we have 24x to the power 4, and we have 4 times 2 minus 8x. We have 3 times 6 minus 18x cubed plus 6. See, it's 46, 42, 48. Okay, I think we can take out 6 as a common factor. So it's 36, 42, 48. It's 8, it's minus 8 x cubed minus 6 x squared. Oh, we have 8 here. We can't take out 6. I think the lowest we can take is a 2. Let's say I take out 2 from on top and below. If I take out 2, I will have minus 24 x cubed minus 13. Oh, it's 36 divided by 2, so it's 18 minus 18 x squared minus 4. And then I take out 2 below again. We have 2 as plus 4x minus 9 You can't take out a common factor anymore.
So we just cancel out the
Yeah,
twos.
it's either yeah, I can leave it here. I think it's better. Is it? Are you okay now?
I I am okay. Thank you so much, ma'am. Sure. Hello?
Okay. This is part of assignment 3, right? The ones that you are doing today.
I think so, ma'am. Yes, yeah.
When is assignment 3 due?
Assignment 2, not 3, ma'am. It is due
it's
on
the
Thursday,
differentiation
the 6th.
Thursday on the 6th.
Yes,
Okay.
ma'am.
Is the application there too? Or that's assignment 4?
I'm not too sure. I'm not too sure.
Yeah, I think the application is assignment 4, if I'm not mistaken. Okay. I think this is the last chapter in
I'm going to mute now, ma'am. Thank you so much for your help.
then, right, I think, yeah, I think it ends that's up. Optimization of function in one variable. Okay. Today we're doing optimization, which is just the process of finding the maximum and the minimum point. Remember, and we said the aim of this module is to minimize the profit, right? Or to minimize the total revenue. So now we are finding the maximum or the minimum points. Okay. For if you are asked to find the maximum and the minimum points, the first thing that you need to do is to find the stationary points. Okay, another thing, remember we said the reason we are doing derivatives is because some other linear functions, they cannot capture the information like the derivatives, like other functions with, like other non-linear functions, like those functions with the curve, right? And then after doing the linear functions, we did optimization, like the process of finding the minimum and the minimum points, right? So again, here we'll be finding the minimum point and the maximum point for non-linear functions, like those functions that are not the straight line functions, like the functions with the curve, right? And I said, if you are asked to find the minimum point or the maximum point, the first thing that you need to do is to find the stationary points. And the stationary points are the points whereby the slope changes, right? From maybe the positive to negative or from the negative to positive. Okay, if the slope changes from positive to negative, we call that the maximum point. And if the slope changes from negative to positive, we call that the minimum point. Like, for example, suppose we are given a function f at x. And f at x is represented using this graph. Let's say we have point A here, and we have point B here. See here, our slope is positive. Okay, let me just write plus. And here, our slope is negative. That's decreasing. Okay, let me just write negative. And we have this point. And I said the point whereby the slope changes, maybe from positive to negative or from negative to positive. We call those points the stationary points. And we said if our graph changes from positive to negative, we call that the stationary point a maximum point, right? And if our function, the slope changes from negative to positive, we call that point a minimum point, right? Okay. This is the equation that we'll use to find the slope of the function. Okay, the slope of the function is the same thing as the first derivative. So to find the slope of the function, we'll use slope equals to f prime of x, and this equals to the derivative of f with respect to x, right? Okay, here the slope changes from positive to negative. Before, okay, let's say we have a graph like this. We have positive numbers here. We have maybe 2, 1, 0, minus 1, minus 2. If we are moving from this side, from positive to negative, before we get to negative, we need to reach 0, right? And I said the slope here, the slope moves from positive to negative. So if this line represents the slope, it's moving from positive to get into negative, it's reached the point whereby it reaches 0 before it gets here. And if this point, it's whereby we move from the slope moved from positive to negative, it means the slope here and then it gets to the point 0. Yeah, we move from negative until positive. So we are moving from negative to positive. If we are moving from negative to positive, you reach 0 first before you get to positive, right? And this is the slope. It's moving from negative to positive, right? For it to get to positive, it has to reach 0, this point, right? And again here, we will find this point by letting the slope to be 0, like letting the derivative to be 0. Okay, let's say you are given a function and you are asked to find these points, these 2 points, A and B, which is like we call this point here the stationary point or the turning point. Okay, to get this point, you have to differentiate once, and then you equate to 0, and then you find those x values. After finding those x values, you take those x values back to your given function, the original function. Do not substitute them back on the first derivative, because if you substitute them there, you'll get 0. You have to get the corresponding point, you have to substitute them on the original equation, the given function, right? Okay, and another thing, remember, I said we have the maximum point and the minimum point. Okay, if we don't have a graph like this, how do you know which one is the minimum point and which one is the maximum point? Okay, you need to find the second derivative to determine which point is the minimum point and which point is the maximum point. Suppose okay, we are given a graph, a function f at x, and you are asked to find the stationary point and determine the nature of those stationary points. If they say you have to determine the nature of the stationary point, it means you have to mention whether the point is a minimum point or the maximum point. Okay. Going back here, we are given f at x, and we are asked to find the stationary points and determine the nature of the stationary point. One, you have to differentiate f. You find f prime at x, right? Then two, you let f prime at x equals 0. And then you solve for the values of x. Let's say you get x star 1. Let's say you get 2 points, x star 1 and x star 2. Okay, we have x star 1 and x star 2. Then the next step is to find the corresponding values, right? To find the corresponding value of f star 1, you take this f star, you substitute it back to f at x. So that means you have x star 1 corresponding to f at x star 1. And then you substitute the second one, which is x star 2. X star 2, you substitute it back to f, and you'll find f of x star 2, right? Then the next part is to determine the nature of these points, like x star 1 and x star 2. Okay, to determine the nature of the stationary point, you need to find the second derivative of that point. Okay, it's 1, 2, right? You find the second derivative and then you substitute your point, which is x star 1, on your second derivative. If x star 1, okay, this is the second derivative, meaning it's this squared of x star 1 over the x squared. Okay, you substitute x star 1. If this here, after substituting, okay, you find the second derivative, you substitute your x star 1. If your results are less than 0, if after substituting x star 1 on your second derivative, if that result you get them, those results you obtain, they're less than 0, then you will say your derivative, okay, your point, that x star 1 is a maximum point. So we have x star 1. Remember, x star 1 corresponds to x star 1, f at x star 1, right? You'll say this point is the maximum point. Or you can say it's a maximum turning point. Again, if your second derivative, you substitute x star 1 and x star 1 is greater than 0, then that means, yeah, okay, greater than 0. This means x star 1 corresponding to f at okay, this is a minimum point. Or you can say it's a minimum turning point. Do we have questions for now? Before we do an example.
Ma'am, can I ask something?
Yes.
Okay, the first derivative, I understand we got extra one. So on the second one, are we still using, we're not gonna equate the second derivative to 0 to get the next extras. We're still using the first extras 1 and 2 on the second to determine the nature.
Yes, okay, after differentiating the second time, getting the second derivative, you just take those extra 1 and extra 2, the one that you obtained after differentiating once and equating to 0. You'll substitute them on the second derivative. There's no need for you to find the points. You have the points now. You just want to find the nature of those points, whether it's a maximum point or a minimum point. So you just find the second derivative. The reason we find the second derivative is because you want to find the nature of our stationary point. The reason we find the first derivative is because we want to find our stationary point.
Okay.
Let's just do an example. Maybe you'll get this. Okay. Let's do this example. Right. Suppose we are given this function and they said we should find the turning point and the nature of our turning point. Right? I said the first thing that you need to do is to find the derivative of your function. Meaning we have to find f prime at x, right? And if we differentiate this function, we have 200 minus 2 times x minus 4 times 2. And the derivative of this function would be minus 4 into x minus 4 times 1. And this is just minus 4 into x minus 4, right? The first derivative of that function. Okay, because you see we have the inner function and the outer function. Okay, and the derivative of 200 is 0. And then the derivative of this, the outer function is, okay, I'll take the outer function as u squared. And the inner function is u, okay? The derivative of minus 2u squared is minus 4, then everything inside the brackets, which is u, then to the power 2 minus 1, that gives you 1, right? So we have minus 4 times 4x to the power 1 times the derivative of the inner function. The inner function is x minus 4. The derivative of x minus 4 is 1, right? So that's why I have 1 here. Then you simplify, you get minus 4 into x minus 4, right? Okay. Then I said the next step is to equate the first derivative into 0 to get your stationary point. Okay, we have, if we equate the first derivative to 0, we'll have minus 4 into x minus 4 equal to 0. Remember, the reason we equate this into 0 is to find the stationary point, which is the x value here. Okay, if we have minus 4 into x minus 4 equal to 0, we divide by minus 4 on both sides, and you'll be left with x minus 4 equals 0, because it's 0 divided by 4, right? And then remember, I'm trying to make x the subdish of the formula, meaning we have to transpose 4 to that side. And if we do that, we'll have x equals 4, because 4 will change its sign once it gets to the other side of the equal sign. So this means we have x star equals 4. Okay, in this case, we only have one stationary point, which is x star equals 4. Sometimes you'll find 2 stationary points, 3 stationary points. It will depend on the function that on that given function, right? We have x star equals 4. I said the next step is to take your x star and substitute it back to the given function. Remember, the given function is f at x equals 200 minus 2, okay, minus 2 times x minus 4 all squared. Okay, we need to substitute 4 here. We get f at 4. F at 4 is equal to 200 minus 2 into 4 minus 4 all squared. 4 minus 4 is 0, so 0 times 2 is 0. And 200 plus 0 is 200. So this means we have our point 4 is to 200. This is our turning point. But now we are asked to find the nature of this point too. We said to find the nature of the turning point, we need to find the second derivative, right? We said that the first derivative is f prime at x is equal to minus 4 into x minus 4, right? And this is the same thing as minus 4x plus 16. To get the second derivative, we need to differentiate the first derivative, right? Okay, if we differentiate minus 4x plus 16, we'll get minus 4, right? And then the next part, the next step is to substitute your stationary point here on the second derivative. We have minus, oh, it's plus 4. We have 4 equals f double prime of 4 is equal to minus 4. And you see this minus 4 is less than 0, right? Since if we substitute our stationary point, which is 4, we get a negative value on the second derivative. That this means 4 is to 200 is the maximum point. Or you can say the maximum turning point, the maximum. Yes. Do you have any questions here? Yes, no.
Yes, ma'am. I have one question.
Okay,
Where you got
listen.
f prime of x is equal to negative 4 into x minus 4 is equal to 4x, negative 4x plus 16. Can you explain that step and why it's like that? Or what you did there?
Okay, you mean from here?
Yeah, where
to
you're pointing,
here.
where you're pointing, yes.
I multiply minus 4 with everything in the bracket. I said minus 4 times x. And
Yeah.
again, minus 4 times minus 4.
Oh, so you just did distribution. Okay.
Yes.
Okay. Okay, thank you.
All right. Any more questions? Okay. If we don't have questions, please try this one.
Hi, ma'am. I have a question. Sorry.
Yes.
Can you please also explain again how you got your first derivative? I got lost there. Just how you got your first derivative.
Okay. Our function was f at x equals 200 minus 2 into x minus 4 all squared, right? Okay. Since this is this, I can say it's the sum of two terms, you can say the derivative of f at x is equal to the derivative of 200 with respect to x minus 2 times the derivative of x minus 4 all squared with respect to x, right? Okay. The derivative of a constant is 0, right? And we have minus 2 times the derivative of x minus 4 to the power 4 to the power 2. So we have, it's like we have g at x equals x minus 4 squared. Okay. You see here we have an inner function and the outer function. We can let our inner function to be u equals x minus 4. That means our outer function is v equals u squared, right? Using the chain rule here, if we have the inner function and the outer function, g prime would be the derivative of the outer function, which is v prime, times the derivative of the inner function, which is u prime, right? But if you differentiate v prime here, you will get 2u, right? Times, if you differentiate u is x minus 4. If you differentiate x minus 4 with respect to x, you get 1, right? But your our u is x minus 4. So we have 2 into x minus 4 times 1. And this is the same thing as, okay, wait, the derivative of, this is u. The derivative of v is 2u. The derivative of u is 1. So if you multiply this further, you will have, 2 into x minus 4. So that means I made a mistake there. Did I write 4? So we have 2 here. We have 2. If we have 2, that means we have 2x plus 8, right? 2x plus 8. If we have 2x plus 8 and we equate to 0, okay, we have minus 2. Oh, we still have to substitute back here. Okay, so we have this minus 2 times this. We have 2 into x minus 4. We said our g prime is 2 into x minus 4, which is, we said our g is this. If this is our g and we are asked to differentiate this to get g prime, and we said if we differentiate this, we get 2 into x minus 4, right? And then I multiply everything by 2. Minus 2 times 4. 2 is minus 4 into x minus 4. So that means I didn't make a mistake up here. It was fine. So you have minus 4 into x minus 4. Is it fine now? Or you still have a question?
No, it's fine. Thank you.
All right. You have 5 minutes. Please work on this one. F at x equals 64x plus 1 over x. Okay, you need to find the stationary point and find the nature of that stationary point. Please, you have 5 minutes. Are you guys winning? Guys, are you winning? Do you want more time or you're done? Again, if you don't want to do it now, you will be forced to do it in the exam.
Ma'am, can you give us 2 minutes?
No problem.
Ma'am,
Yes.
may I ask something? Yeah, but okay, with this one, I just wanted to ask first. After getting the first derivative, we equate to 0. Then is it possible to get like more than 2 roots? Because
Like?
I'm getting like plus or minus. That means it's a plus or a minus. That means it's actually 2 roots.
Oh, yes. I said you can get one or more roots.
Oh, okay.
Are you guys done? Okay, please give me the first derivative at least.
It's 64 minus x to the power -2.
And if we equate this to 0,
It's actually 64. Yeah, we get that. All right.
Isn't
Ma'am,
it
I have a fraction
64
for x
plus-
if you equate it to 0.
correct?
I'm saying, isn't it 64 minus x 1 over x squared?
Okay, this is x. Oh, you said 1 over x squared equals 64.
It's 64 minus x squared.
I think it's gonna be like x squared is going to be 1 over 64.
Did you all get this one?
Yes.
And then the second derivative?
2x cubed. Oh, not cubed, -3, sorry.
Okay. Then if you
Yes.
substitute plus 1 over 8,
I got 1024.
1024. And if you substitute minus 1 over 8. Okay, first, this is positive. Since f prime prime of 1 over 8 is positive, okay, greater than 0, that means this point is okay. You can take this 1 over 8 and substitute back to the original equation, which is this one, right? And then after substituting there, and then you come to the second derivative, you substitute your 1 over 8, you get 124. That means that point is a minimum point since 124 is greater than 0. Okay, if you substitute minus 1 over 8, what do we get?
I think it's 1024, not 124.
Yes, ma'am, it's
Minus
1000.
124.
1024.
Oh, it's
1024.
1,224.
No, 1024.
1024. Okay.
Yes.
Okay. Since this is negative, is less than 0, this point where x is equal to minus 1 over 8 is the maximum point. And since this is positive, is greater than 0, that means that where x is equal to 1 over 8, that is the minimum turning point. Less than 0, minimum. Greater than 0. Oh, less than 0. This one. Okay. Less than 0 is positive. No, it's negative. So it means is a maximum point. Then less than 0 is negative. That means it's a minimum point. Yeah, so we have the max here and the mean here. Okay. I wanted to do this one
Ask a question.
with 2 points. Yes.
Okay. So you solve for x and you got negative 1/8. And why do you have positive 1/8?
Where is positive 1/x?
You have it here. Oh,
Positive
you have it here
1/x.
for 1/8.
1/8.
Yeah. You
Okay,
have two,
here
one
we
with
have
positive and one with
x
negative.
squared. Here we have x squared equal to 1/64, right?
Yes.
To cancel this x squared, we need to add a square root on both sides. If we add a square root on both sides, this would give us x equals plus or minus square root of this.
Oh, okay. So plus or minus. Okay. Okay, thank you.
Yes. All right. Okay, I guess since we have this one with 2 roots, there is no need to do this one, but please do it in your extra time. Again, you differentiate one, you solve for x, and then you differentiate twice, you substitute your x. If you get, if that second derivative is less than 0, that is a maximum point. If it's greater than 0, that is a minimum point. Okay, remember here, if you can't factorize, you use this the quadratic formula. Do we have questions before we move on to another part?
Yes, ma'am.
I guess not.
Yes, I have a
I'm
question.
listening.
How come in this example you
Yeah, I'm
substituted
listening.
the yes, in this example, how come you substituted the x into the second derivative and not the first function, that is?
You only substitute in the first function if you want to find the corresponding value of your x. Then if you want to find the nature of that point, you substitute on the second derivative. Right? Okay.
Oh, okay, okay. Thank you.
Yes, it's just to find the corresponding y value. Right? Because if you are asked to find the stationary point or coordinates, you'll have to find the other corresponding x value by substituting back to the original function. But still, after finding that as a value, you still have to substitute your x on the second derivative to find the nature of that point. But the corresponding value, it's not that important unless you are asked to find it as a coordinate, not just as an x value, maximum x value or minimum x value. Okay, please don't forget to do this one as a practice.
Could I please see the question again?
Thank you.
Okay, now the next section is to find the interval whereby the function is increasing or decreasing. Now, we are not asked to find the maximum point or the minimum point. You are asked to find the interval whereby your function f at x is increasing or decreasing, right? Okay. After finding the stationary point and you determine their nature, it would be easy for you to find whether the graph is your function is increasing or decreasing. Okay, suppose we are given a function f at x equals minus x cubed plus 9x squared minus 24x plus 26. Let's say we are asked to find to determine where this function is increasing or decreasing, right? The first thing that you need to find is the stationary point. You find the stationary point by finding the first derivative and equate it to 0. Okay, if we are given f at x as in this, the derivative of this, you'll find the derivative of this by using the power rule, right? If we differentiate that, you'll have minus 3x squared plus 18x minus 24, right? And then you equate this to 0. If you equate this to 0, you should find minus 3x squared plus 18x minus 24 equals 0. You see, we have a common factor here in this function of minus 3. If we take out the common factor, we'll have minus 3 into x squared plus, it's minus 6x plus 8 equals 0. Okay, you can now divide by minus 3 on both sides. If you do that, you'll have x squared minus 6x plus 8 equals to 0. Remember, the reason we equated the first derivative to 0 is to find the stationary point, like to find our x values. We can factorize here to find our x values. It's either you factorize, but if you can't find the factors and it's wasting time, just use the quadratic formula and still get the same thing, right? If you solve this, you'll have x equals or x equals 2. We have two values, right? Okay. We now have our stationary points. The next step is to find the second derivative. If the first derivative is minus 3x squared plus 18x minus 24, then the second derivative will be minus 6x plus 18, right? We have our second derivative. We substitute our point on the second derivative. Okay, if we substitute our point, we'll have f prime prime at 4. We have f prime prime at 4. If you put 4 here, you will have minus 8 times 4 plus 18. That is minus 6. You see, this means here we have the maximum point, right? Okay, and if you substitute our second point, which is 2, if you substitute 2 here, we have -6 times 2 plus 18, that is +6, since greater than 0. That means you have a minimum point at x equals 2. So this means we have something like this. We have 2, we have 4. We said at x equals 2, this is a minimum point, right? And we said at x equals 4, we have a maximum point. If this is the minimum point at 2, and this is the maximum point at 4, that means we'll have something like this. Okay, this is our 4. We'll have something like this, and then it's a minimum and the maximum, right? Since this is it's the minimum, that means from here to this point, our graph, our slope is increasing, right? And if this is the maximum point, that means from here to the x value, which we don't know because this graph is still continuing, that means the graph is decreasing, right? And if this is the minimum point, that means from here to this point, our graph is decreasing again. So if we were asked to find the interval whereby your graph is increasing or decreasing, you see from 2 until 4, your graph is increasing. But you don't include x equals 2 and x equals 4, because you know at x equals 2 and x equals 4, your slope is it's 0. So to write that means in 2 and 4, to say you are excluding them, you need to put curly brackets, right? Because if you put a square bracket, that means you are including it. You are including them. So you can say from 4 to 2, your graph is increasing, right? And from this value, this side, which you don't know, if you go this side, yeah, your x values, they are decreasing. If they are decreasing, that means they are going to negative infinity, right? So that means you have minus infinity. Again, for infinity, you don't include infinity, you put curly brackets on them. So this means you have minus infinity until it gets to 2, until 2. But 2 again is not included here, since at 2 we have 0. Okay, so this is decreasing, right? And again, we said from 4 to this side, which we don't know, our graph is decreasing again. So that means we have 4 is 2. If our graph goes this side, our x value is increasing. It's going to 5, 6, 7 until positive infinity, until that number we don't know. And if we don't know that number and it's increasing, we say it's positive infinity. So it's decreasing. So it's decreasing between -2 to minus infinity to 2 and 4 to infinity. And it's increasing from 2 to 4. Do we have questions?
Hi, ma'am. I only have one question. I understand everything you said about the intervals. I only want to know, how did you plot this graph with the points you were given? Because you were given you were given
Your kids are making noise.
Bible. Yeah, ma'am. I was asking how do you plot the points do you make this graph from the points you are given? That's what I don't understand only. The rest of the stuff you explained after that, I understand.
Okay, I only wrote 2 points, right?
Yes.
It's just a sketch. Okay, if we have 0 here, we have 1, 2, 3, 4, right? And we are told that at 2, we have a minimum point. It can be here, it can be here, it can be here. I don't know where I didn't find the corresponding value of 2, but I know that it's the minimum. If it's the minimum, that means it's like this.
Oh, so when
facing
we
up.
substitute,
And at our school, that's 4.
so
Yes?
when we're substituting and finding the corresponding point, do we not plot that point?
You can find the point, the corresponding point, but there is no need, because I just wanted the shape of the graph for me to know. Okay, to determine the interval whereby the function is increasing, you need to find the x values whereby that function is increasing or decreasing. So there is no need for you to find the corresponding f values. But if you can't do it like this, you can find the corresponding f values and put dotted lines, and then you get the shape of your graph. But I found it easy like this, that I found just 2 points, which is the minimum and the maximum. And remember, I told you that's the minimum. It's facing up. It's like this, and the maximum is facing down.
Oh, okay.
And if the minimum is facing up and is facing down, remember there are only 2 stationary points here, right? If there are only 2 stationary points, that means we don't have other curves, because at the stationary points, it's where you find the turning point, the curve. If we only have 2 curves, that means here we will have a straight line, a smooth line from here to here. We won't have like we won't have a curve. So if we won't have a curve, that means the only way we can move from here to here is just draw a smooth line like this.
Okay,
And,
okay, I
and
understand.
I said if we are moving, okay, to get the maximum point, you need to move. So it's when we are moving from positive to negative. So to get here, we were moving from positive to negative, meaning if here it's from positive to negative, that means the graph was increasing in this part, right? So if here it's we get to the minimum, that means we're moving from negative to positive. If this side is negative, our graph is, the slope is negative, that means our graph was decreasing. And if here the slope is negative, since we are moving from positive to negative, that means the graph here, since the slope is decreasing, that means the graph here is decreasing since the slope is negative. And I know this is 2, this is 4. Okay, there is no need to find other points, because you know everything here, x is decreasing until, okay, you can say, and someone may say until 5, another one may say until 6, but we need the point that covers everything, all those 5, all those -5, -6, -7, and that point is, it's minus infinity. Okay, so this is minus infinity until 2. But here we know it's from 2 and 4, from 2 until 4. So, but then 2 and 4, they are not included. So it's from 2 until 4. I wanted the shape only here. There is no need to draw the exact function. You just want to find the idea, the shape. Perfect.
Okay, thank you, ma'am.
Did I answer your question?
Yes, ma'am. Thank you. Thank you so much.
Yes,
All right. Thank you. Do we have? Yes.
ma'am, I do have one question here. I don't know whether you can clarify for me between the maximum and minimum, because you know when you substituted 4, we got -6 as the answer. Is that minimum or maximum?
When I substituted 4,
Yes, when you added 4 on our second derivative, we got -6. And then when you added 2, we got +6. So which one is a minimum and which one is a maximum?
are these values correct? Okay. When we substitute 4, we have 6 times 4 plus 18. So we have -24 plus 18, which is -6. Since it's -6, that means it's less than 0. And if it's less than 0, that is a maximum point. You see, it's a maximum point. And we substitute 2, we get +6, which is a minimum point.
Okay.
Is it okay?
Yes.
All right.
Thank you.
Okay, no problem. Please let's try this together. I know we only have 1 minute. F at x equals x squared minus 18 x plus 11. Okay. Please do this one in your spare time. 3x squared minus 0.1 x cubed. You do this one in your own time. Please, let's do this together. We have 3 minutes to do this one. Find the interval whereby this function is increasing or decreasing.
Can I ask which one are we doing now?
We are doing this one now.
Okay.
Guys, do you want more time or you're fine?
I think I have it.
We are
Okay,
we
what
are
did
fine,
you
ma'am.
get on your first derivative?
The derivative is 2x minus
Did
18.
you all get this one as our first derivative?
Oh,
Yes.
yes.
Okay. Then as our x value, stationary point, what did you get?
9.
Did you all get 9?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. Second derivative,
Just 2.
okay? We only have one stationary point, right? Okay. At x equals 9. What do we get if we substitute 9 there? Like our f at 9. We get something like, okay, this is the minimum value. We get something like this, right? If at 9 we have a shape like this facing up, that means from 9 to this side, our graph is increasing. And from 9 to this side, our graph is decreasing. So here you can say from minus infinity to 9, your graph is decreasing. And from 9 to positive infinity, because it goes this way, your graph is increasing. Yeah. If we don't have questions, I think I'll see you guys that day, which is, I think it's the 5th. Yeah.
Sorry, ma'am. Can I just see
Yes.
that problem you gave to do an
Yes.
extra?
Okay.
Thank you.
Okay. If we are fast on Wednesday, I will try to cover the application of derivatives. And if we are done, we are going to go to complete assignment 3. But if we don't finish on Wednesday, I guess we'll have to come on Monday. That's a holiday, I think. Yeah, we'll see. Yeah. If you guys don't have any questions for now, have a lovely evening.
Oh,
Thank
ma'am,
you for
can I
your
ask
time.
one more thing? Can I ask just one more thing, just to have clarity on that one? When we have 2 points,
Yes.
like previous example, how do we explain that? It was 2 and 4. We say it's in